My name is Tan. I'm an engineer for Zealous Soccer. I also maintain a bunch of NFL and fantasy football art packages and mentor at R4DS online learning community. And today I'm going to be talking about effective logging for Shiny. You can find the materials and the slides at tanho.ca/logging-shiny. And let's begin. Does that work? Yes. Cool. Okay, so let's talk about some motivations, why I talk on logging. Basically, it comes out of doing a lot of debugging. So as many of us can relate to, there are a couple of approaches to debugging Shiny apps. First of all, you can read the log files. And when that fails, you can step through the code and do browser or breakpoints. You can use some pair programming, talk to people, your colleagues, or help online. You can consult Stack Overflow and see if there's something you can copy and paste in there. And then when things get really dire, you can make a pact with the devil, or you can just rebrand the bug as a feature, right? And so quite frequently, we'll start with log files. And this is kind of where most, you spend a lot of time when you're debugging, you start with the log files basically every time. And so one day, not that long ago, but a couple months ago, I wanted to kind of debug some of our production apps and had a lot of trouble getting the log files in our production Shiny apps. We'll talk about that in a second, but basically I spent like an hour trying to figure out which logs, which files, where the logs are stored, that sort of thing. And then when I finally did get there, I found out the log files weren't even useful. We had a, it failed. That's all it said, basically. And then I was like, okay, well, clearly I need to figure out some best practices here. There must be some resources that we could use and improve on to kind of make this a little better for us. And I wanted to have some documentation. I could just spout opinions or whatever, but in a team setting, you want to have some kind of documentation and best practices. And so I looked around, I couldn't find any. Lots of stuff about JavaScript. There's a package called ShinyLogs, which kind of monitors the JavaScript side of things and kind of writes everything. But it doesn't control the R logic, and usually that's where the problem is. So I had a heck of a time trying to find that best practices in R and in Shiny. So this talk is the book or the resources that I wanted to read when I was looking for it. And so today we're going to talk about kind of two things. We'll start with app level logging, kind of go in depth there, and then we'll talk about some of the improvements to the production level logging systems that I put in. And yeah, so let's start with app level logging. So the first question is, who are you logging for, right? And who are the main personas that you want to log for? In this case, you've got humans, developers, and you've got machines. So how do you write good logs for humans? Well, you want them to be easy to scan visually, because usually humans are eyeballing things, and so it's, if it's a wall of text, it's really hard to read. Humans want it to be easy to understand, of course. You want to kind of pick out the key words right away. And we really like good summaries, we're not parsing every piece of every word or whatever. We want the right level, the important stuff, just bring it to the top so we can see it really comfortably. In other words, we really like stuff that prints to the console and then kind of that level, that size of logs. And on the other hand, machines can handle things a little differently. So they want things that are easy to ingest. Things that we want we want it to be accurate. So everything basically just dump out the whole stack. And we want it to be complete. Right, so we don't want it to just kind of, machines can handle a lot of information, so we don't have to guess there. In other words, machines kind of want structured data. JSON works really well because it can handle nested structures or lists or whatever, and everything's really well labeled, and we can ingest that pretty comfortably. So when you're thinking about logging for formatting purposes, you want to be able to do both, I think. You want to be able to have really good log messages for humans, and you want it to be easy to read. And you also want machines to be able to ingest it comfortably. OK, so let's talk about what I should be logging in my app. Actually, this is a really difficult question because every app is a little different. And I could prescribed things here, but that might not actually be relevant in some cases, depending on how complex the app is or whatever. Kind of reframing it, a more important question is, what question should my logs help me answer? And so we kind of start with errors, right? So did we handle the error gracefully, right? Have we already kind of got some kind of handling for this error? Do we know the cause of this error? Can we get the context of the error? Can we reproduce the error? Just like these sorts of questions where like, if you can provide this information, it makes our lives much easier. A really common one for me, a lot of things, especially when we talk about Docker and installing packages and so on. I want to know, is this app running with the latest version of our internal packages, i.e. is this package outdated? Did someone already work on this? Does it have the latest or the correct version of the dependencies? So sometimes we upgrade our dependencies and then things are broken. What's the difference between like the latest correct version and the latest version and the last version that was correct? Kind of compare them, figure out where the problem might come from. Apps, Docker containers, and apps usually refer to environment variables or package options. So are those being set properly? Are they referring to, is it referring to the right database, or does it have the right credentials? So I want to be able to kind of answer those questions with my logs. Next, we want to talk about users. So if we're kind of debugging things, we want to know who's using the app, what pages, sections, or processes are they using, what actions do they take, are they doing anything unexpected or suspicious? So if you can kind of raise up some validation early on, and they're failing their password input 5 times or something, that might not be kosher. Let's put it that way. Another thing we could log, expensive functions and external requests. So anytime you talk to something else, you kind of want to keep track of what's going on. So which API, database, or even background jobs should be logged like that? What kind of arguments, what query did we request from it? How long did it take? When did it start? When did it end? And lastly, of course, did each step of that process complete successfully? If it's a long process, we've got progress markers and so on. Okay, so lots of questions. You can ask any sorts of questions of your logs, or you can log to kind of proactively tackle some of these. But we come up with a problem. Alert fatigue. If you kind of log everything at the same level, you have to read through everything to get there. And so if you've got your logs monitoring and it's screaming at you, and you've got Slack messages coming in willy-nilly, you get alert fatigue. And so what that means is basically you start to subconsciously or consciously ignore the fact that your logs keep going off. And so the solution to that is categorizing it into alert levels. So in production, we start at the info level, so like base information level, that's where most of your logs will be. And then you kind of separate things into like warnings, errors, and then if the app crashes, it's fatal. And then when we're debugging or working on it locally, we set the debug level to debug, and that gives you like the low-level details to kind of work on things. So what goes in each alert level? Debugging. The debug level is for print debugging. So anything that you would do to kind of keep track of what's going on in each process is a debug level log to me. So things like input values, reactive state, helpful context for diagnostics, that goes in debug. It also is where I would put things like progress tracking within larger functions. You don't always need to do that necessarily, but for larger functions that run entirely within your app, this is where I would put it. Info levels for session level stuff. So this is where I would put that like user authentication information, system information, package information. It's where I'd put performance timings of like the major or expensive calculations, and it's also where I would track significant user actions. So if they're visiting this page, triggering some button, that's where that would go. Warn is kind of like R's warning, but I wouldn't actually, so I would not recommend just piping anything that's an R warning to the warn level, because R will warn about basically everything. And you don't want to get warnings that the NAs have been dropped. That's pretty good, right? That's a good thing. So this is for like things that you pre-identify as edge cases, suspicious behaviors, unusual inputs or states that still produce output. So if you're expecting the number to be 5 and it's 5,000, that might be a warning. Or it could just be an error, right? So if we're handling the error, if our errors are basically anything that's handled gracefully by the app and we stop it. So if there's things like input and argument validation, we want that to be kind of like an error and say, so if we can't process something like 5,000 times, or you don't want to simulate it 5,000 times, it would be like a log error or something. It might be a log warn, but basically we just stop the app from running and kind of stop that process from running, but continue the app going forward. And we also, anything that we've already identified that could fail, and we've already wrapped it in try catch, we want to put in this log error level. And lastly, fatal is anything that causes an app to crash, i.e. shiny gray screens. This is basically corresponds to where R calls stop, and then if R calls stop within your app, it will crash your app unless you properly handled it. Okay, so we talked a lot about this. So how should I log things in my app? And this is really a question about how do you choose a logging package? Well, in R and on CRAN specifically, there are many options. So there's futile logger, log4r, logger, logging, logit. So that's the theme here. Lumberjack, someone got creative. I like that one. rlog, rsyslog, all kinds of things, right? So how do you choose? So you're looking at all these options. How do you choose between them? I couldn't really think of a better way. Like, I've set out the criteria of what kind of logging I want to do. And so I went through a couple of these and experimented. And I settled on logger as my logger of choice. This might not be for everyone, but to me it works really well because it's got a pretty familiar syntax. It even uses glue, so you can do some really nice interpolation with it. It's performant and it's pretty lightweight. It's not a huge dependency suck. It's actively maintained. It's flexible, so it covers the alert levels. It has custom layouts and formatting, so you can write things as JSON or come up with your own custom print methods. It works for multiple destinations, so you can get it to write to console, to files, to Slack. It's got some integrations for that if you wanted to. And also, one really cool thing here is that you can log as an asynchronous process. So that means that your R process that's running your code doesn't even have to be blocked by logging things. So it doesn't add extra load in terms of the app performance. So that's my recommendation. I use it now, so works pretty good. And show you some useful tricks. So people who've kind of been around the block know most of that stuff. Here's some useful tricks that I found. We made a customized session info. We call it sitrep. And basically what this does is it surfaces all of that version information that I talked about earlier, but kind of in a human-friendly way with nice headers and make it easy to read. So at the top, you've got the system information. It's got the R version running under Ubuntu 20.04. List all the environment variables that are relevant. So we've got like a regex pattern, basically, to identify anything that starts with zealous is internal variables that we set. Anything that starts with shiny proxy is the variables that are relevant for shiny proxy. And this is really convenient also for tracking users in the app's case. Internal packages we surface separately. So we've got utils, plots, shiny, that's shiny utility code, models. So the versions of those things are kind of surfaced right there, so it's not hard to find. We also know which internal packages aren't installed, so we've got some validate, monitoring, mapping, scraping, blah, 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 that's not installed. And so it's just easy to kind of validate that, yeah, we don't have that installed on here. We don't use package options, but sometimes it's useful to kind of, it does exist, but in this case, we didn't have any set. And then we've got the dependency versions, so truncated for our purposes here, but basically, you can check through all of the dependencies, make sure that it only shows, check the versions and so on. The code's here, so it's in the repo. It's quite a lot of code because we kind of were very deliberate about how custom everything was. And of course, in the true who you're logging for spirit, we also convert it to JSON, so the machine can read this much easier than when trying to parse that text string with all the spaces and bullets and the headers. Kind of makes it awful, right? So, machine's much happier reading this. This is pretty printed, but obviously it would take less space if you just compressed it. Another thing, I experimented with this, came up with this process for logging app crashes and fatal errors. It's kind of off-label. Anytime you use get, I kind of feel a little queasy about things. But it's not too off-label. The reason why, so basically what this is doing is it's creating a function that runs anytime there's a shiny error. The reason why it doesn't accept any arguments and why I couldn't just get E from the call is that I think it's meant to be used with recover or traceback. In our case, we want to kind of attach a logger to it and then continue with the usual process. So it gets the log, it gets the stack trace, and then it sends log fatal with the message, stack trace, systime, and sitrep. And to kind of prove that it works, I set up a example. Basically, here on the left, you've got an app that all it does is takes this input, passes it to the stop call when you press the button. And on the right, I've got active logging or tailing of this log file. And you can kind of see when you press stop, the app crashes like usual. And on the right, you've got JSON logs that have been written to the message. So it's not super fancy or anything, but when you pair that, in this case, I think I simplified it for the sake of putting it on screen. But it would send a sit rep at the same time, it send the full stack trace. So it makes it a little easier when it fails to kind of see what's happening in that fatal message, right? OK, so talked a lot about the app level. Let's go back to logging as a production system. Here's me trying to, here's a callback to me trying to find the log files in production Shiny apps. Understand why that is. Here's the Shiny infrastructure that we have. It's not complicated. We use Shiny proxy. So we've got a development server. This got our studio server on it and so on. And then we have two servers. There's a production Shiny proxy server in the US for some clients. And then there's a production Shiny proxy server in the EU for our EU clients. The way Shiny proxy works is that it spawns one container for each user for each app. And so you've got, from there, you've got user 1's prod app container, user 2, user 3, user 4, et cetera. And so when you're debugging things and trying to get to the logs, you've got to SSH onto the development server. From that server, you have to SSH into the prod server, the correct prod server. That's tripped me up a bunch of times. You got to find that container's log files, figure out where it put it, try to find the specific error in the log files, and there's usually hundreds, and then you pray. I personally pray that my Vim foo isn't too rusty, right? You've got SSH, so you don't have our studio here. That I'm looking at the right set of log files. There's usually hundreds or thousands. We're not great about log rotate. And that the logs are actually useful. We talked about the useful part already, but it would be really nice if we had a centralized system for all of the logs. And so back to our dog friend, looking at all the options. You got Grafana, Loki, and Kubernetes. This is what Shiny Proxy recommends as its monitoring stack, which is an option for us. You got AWS CloudWatch, so we run all that stuff on AWS, so CloudWatch could be a natural fit here. Splunk has been around for a while. I asked my JavaScript friend what the log stuff best in class was now, and he's listed these three things: Datadog, Sentry, and Amplitude. There's other proprietary tools that I didn't list here, and of course, you can roll your own thing. So how do you choose between these? Unlike Logger, I didn't want to go through and try every single one personally, so kind of came up with kind of a set of like a process for how I would choose one. And so there is no such thing as a one-size-fits-all solution here. The right solution, in my mind, is the one that fits within the existing architecture, has the correct trade-off of simplicity and features, is easy to implement, and the one that actually gets used, right? So, it doesn't have to be super complicated. So I started with what we had, which is Shiny Proxy, and I found this in the documentation. Of course, documentation actually there when you read it. It's also possible to store the container log files in an S3 backend using the following settings. And so, this set a light bulb off in my head. So if we wanted to implement something like this, what actually happened when we implemented it was, well, we've got production Shiny Proxy servers. We get it to push stuff into an S3 bucket. The cron job, we had then from our development server, we've got a cron job that reads S3 logs into the database. And from there, of course, we like Shiny. So we set up a Shiny app that does some log monitoring and searching. We've already got some integrations for a Slack summary report. So we just summarize that data into a summary on every day of how many users and whatever hit it, and how many fatal errors or whatever happened. And then if there's a big outage or something, we've got Slack alarms on major failures. So it pings us that something's broken. We set some thresholds that made sense. It actually works so well that we updated our data ingest pipelines. We also ingest our data in R. And we basically do the same thing now. So we pushed all the data ingest logs into the S3 bucket and extended the app. So this is good. How might we outgrow the system, right? So when you plan these kinds of infrastructure, when would it stop making sense for us? So if we had to ingest logs from other things, databases, things that don't log naturally in JSON, that would be a good time to kind of start rethinking that. If we couldn't use one S3 bucket for all logs, for whatever reason, we've had clients, we can't just push stuff cross region. If we have log volume increasing beyond capacity, so we started logging every click or something, that would be kind of crazy to ingest all the time. If we needed real-time latency kind of monitoring or A/B testing of metrics and modeling on that, lots of ways that things could happen. And I probably didn't even think there's a couple here. But really, in my opinion, until we grow it, this system works really well for us. OK, so summing up some takeaways. Logging is about being proactive for future debugging. It's also a process that generates data that can guide improvements, right? So it helps you find optimizations. And it's also a production system that you can improve on iteratively, so you don't have to have a perfect solution right away. Unfortunately, logging might not always be enough to save you from a painful debugging experience, because you'll have to find the real problem. Thank you.